We're going to continue our exploration of nomenclature of aromatics. And this one, we have a heterocycle known as pyrrole. Pyrrole covers this. Heterocycles are cycles that have an atom other than carbon in the ring. It's clearly qualified. All heterocycles, the atom that is not carbon in the ring is position number 1. You may have forgotten that. Position number 1 is the heteroatom, the one that's not carbon. The lowest numbering to get to a group would be this. The group is an amino group with a methyl on it. So 3 N-methylamino and pyrrole. Not bad. This one's new, but you have to learn it. This one is probably the most important base in all of biochemistry. This is not a biochemical here, but when that circle is attached to a protein, it's part of an amino acid called imidazole. Sorry, take that back. The circle is called imidazole. It's part of the amino acid called histidine. You've heard of histidine, maybe. I know you've heard of histamine. That's when histidine loses a carboxylate, and then you feel allergic things happening because histamine causes allergic response. Anyway, you need to learn this. This circle is called imidazole. And the numbering would be 1, 2, 3. One of the ends has to be 1. You got to go to the next end and keep the numbers as low as possible. So we got isopropyl on the second position. Sorry, second position. 2 isopropyl. Imidazole. The imidazole base is found in the amino acid called histidine, and we'll see more on that when we get to biochemistry. Hey, this is naphthalene with an alcohol on it. Naphthalene with an alcohol can be called naphthol. And I want to remind you, there's only 2 positions in naphthalene. You can also call it beta hydroxynaphthalene if you want. Naphthol is a lot nicer. I think I spelled it wrong though. Naph. P-T-H, naphthalene. Little listexia there. Naphthalene becomes naphthol. Sorry about that. Then I have another typo. Nat. There's no T there. Alpha nitronaphthalene. Oh. Yeah, well, there you go. Dry naphthalene. Alpha nitro, one of the positions that's 1 away from the bridgehead. There's 4 of them, just pick one. That's the alpha position. You got alpha, you got beta. Then we got fluoro. Got some serious typos going on here. The first O has to be snuck in between the U and the R. That's how you spell fluorine. Fluoromethyl is a group. It's a methyl group. And we have to learn how to draw imidazole. How do you draw imidazole? Well, you draw pyrrole. Here's parole. It's not imidazole. There's parole. Take one of the corners that's 2 positions away from the nitrogen, put a nitrogen there. There's imidazole. Based on our numbering from our first one, I realized 3-fluoromethylimidazole. Hey, that H has got to go away, doesn't it? Position 1, 2, 3. 1, 2, 3. And it's replaced by a group. I think it would have been better to say N-fluoromethyl, wouldn't it? In this case, it would have been clearer, wouldn't it? But it is what it is. We have what we have. Get rid of the H. CH2 goes to an F. That's a fluorine on a methyl, also known as fluoromethyl. Okay. Then terthexylpyridine. Pyridine is azabenzene. What? I didn't tell you that before. Pyridine. Did you know you can call it azabenzene? You can put aza in a name and it just means a carbon has been replaced by a nitrogen. It's very general. Aza. And position 1 is the nitrogen. So off 3, you draw a chicken foot. The chicken foot only gets you to 4 carbons. That's a tert's butyl. Add 2 to one of the feet. 1, 2, terthexyl. Done. And that brings to a conclusion this segment.